Class, I just realized I did not do a review for the similar triangles. Or the video. So I'm doing the videos now, and hopefully that will help you with the review. Just want to make sure you know how to do it. Instead of sending out the review, I'm just going to have you watch the videos, and hopefully you can see how you did on them. All right, so this is the review for the triangle similarity. Please print them out first, the review out. And once you print it out, then you can do the problems. I'm just going to go through half now and then half later, but here are the first few. All right, so the first thing you're going to do on number one, it asks if the triangles are similar, and the only thing you have are a couple of angles in each triangle. So the only triangle similarity proof you could use is angle-angle similarity, but you need all three angles. So if you take, oops, I need a pen. So if you take 180 and subtract 74 plus 45, the sum of the other two angles, and get that angle, then you'll know for sure if you have any congruent angles. And actually, you don't even really have to do that. You don't have anything that's similar already. But anyway, you don't really have anything similar. This one's 61 degrees. You need to have all three congruent angles, or specifically just two, which when you have two, then you really have three. But we don't have that. So no, not similar, no congruent angles is your answer to that one. All right, number two, are these triangles similar? So you have this triangle, and then you have this triangle. Okay, to check for similarity on this one, because you have a right angle, you would just need to check the other angle, which we have a reflexive angle at angle T. So that angle belongs to the little green triangle and the larger blue triangle, and they are the same. So, and we also have a 90-degree angle. So we have one angle T that's congruent to angle T, and then you have the other two right angles. So by angle-angle similarity, then you would say, yep, those are similar. So then, since they are similar, we have to fill out the statement. Triangle PQT is similar to triangle. So we start at P, so we need to start at R. And then Q is congruent to S, and then T is congruent to T. So triangle RST. All right. Next one, number three, are these triangles similar? You have three sides, so the only thing you can do is check side, side, side. Oh, you know what? I didn't write no and yes. Okay. Sorry, just remember that. So are these triangles similar? To know that, you have to check if all side, side, sides are similar. So, or the ratio of corresponding sides are equal. So what I like to do is I like to line up small, medium, large angles for the small triangle, and then small, medium, and large for the large triangle. And that allows me to get my side ratios. And then I use my calculator to find out what the actual ratio is. So 15 divided 42 is 0.357. 25 divided 70 is 0.357. And I'm checking the rest of it is the same as well. 30 divided 84. 0.357. So everything is indeed equal. So by side, side, side similarity, those triangles are also similar. All right, so TUV. So TUV. So let me just do this. So the small side is 42 and 15. And then the medium side is 70 and 25. All right, so that allows me to set up one angle there. Whoops, right there. So between the green and the purple is an angle. And then on the end of the green, I have an angle, and the end of the pink, I have an angle, and that allows me to line up angles. So T belongs to Q because they both have one arc. U belongs to, it has three arcs, so R has three arcs. And V has two arcs, so S has two arcs. And that's how I would set up the similar triangle statement for that one. All right, the next one, number 4, are these triangles similar? And those were yes. Sorry. I need to make sure that I do that. I'm going to post this. So I need to make sure I mark yes or no on these. Okay, so we have an overlapping triangle scenario here again. So this is my smaller triangle. This is my larger triangle. All right, so I have 88 over 104, and that's going to equal 110. So notice that we have this little green side is 88, and then the blue side is 104. I have to do the same thing. I have to take the green over the blue. I don't have the blue, the whole side, but if I add the two together, 110 and 20, then I get 130, which is the whole side. All right, so then I have the angle in between. That angle K, it's a reflexive angle, so I know it's congruent to itself and it overlaps the other angle. So I just need to check 88 divide 104 and 110 divide 130 and see what that is. And I have the same thing in both cases, 0.846, 0.846, so good to go. That is going to be a wrapper. Notice how it wraps around side, angle, side. So side, angle, side similarity. And then K, it looks like they're just overlapping. K belongs to K, L belongs to B, because that one's going to be L and B. And then M belongs to C. All right. Okay, find the missing variable or side. Now the trick here is to make sure you line up the correct measurements. So TS has to belong to, it's the first two, so ES. So those are the two sides that are corresponding. So you would do 15 over 50 is equal to, and then the other two, 24 over 5x minus 10. Okay, now when I do this, I do a little trick that helps me out. I divide out anything, if I can, in order to make my numbers smaller. And 15 and 50 are both divisible by 5. If I divide a 5 out of 15, I get 3. If I divide a 5 out of 50, I get 10. And 3/10 is much smaller than 15/50 and much easier to work with. So I still cross multiply. Make sure you put parentheses around those, any binomials, such as 5x minus 10. So 3 times 5x is 15x, minus 3 times 10 is 30. And that's equal to 10 times 24, which is 240. Notice how I simplify that fraction, and I get numbers that are much easier to work with. So you're going to add 30 to both sides. So you get 15x is 270, and then 270 divide 15 is 18. So x is 18, and that's what it asked for. So that was pretty easy that way. And I like to just make sure I mark a side so I know which of the two sides belongs to which. You have to set up those proportions properly, and that's done by checking your similarity statement for the sides that are corresponding. So US, I like to look at US. Up here, US are the last two, so it belongs to DB, side right here. So they're color-coded there. I have 48 over 108 is going to be equal to my other side that's corresponding are CD. In here it's first two and then TS, so those two are the corresponding sides. So 48 to 108, I have to start back at 68 to 11x plus 10. All right, now I can't divide anything out of the right ratio, but of the left I can. If I divide out, what's divisible? 12. 12 into 48 is 4. 12 into 108 is 9. And that makes my number smaller. 4 times 11x is 44x plus 4 times 10 is 40. And that's equal to 9 times 68. And that's 612. If I subtract 40 from 612, I get 572. And if I divide by 44, I get x is 13. That's not what I was asked to find, though. I was asked to find TS, so I need to substitute it back into TS. So TS is 11x, so 11 times 13 plus 10. So 11 times 13 plus 10 is 153. So that's TS. All right. Okay. Let's move on to the next one. Okay, so the next two are proofs. You have given NK over ML is equal to JK over HL. So what you'll do there, you're also given parallel, NK is parallel to ML. Let's mark that. NK is parallel to ML. So those are parallel. All right, and then we have the sides. This just says that two sides are proportional. Okay, now with these two parallel lines, we know that corresponding angles are congruent. Okay? So that's one thing that we know, and then we know these sides, and we can check them. So NK over ML is equal to JK, let me get a different color, JK over HL. So that gives us a side angle side similar side angle side similarity proof. The two triangles are similar by side angle side. It's a wrapper. We have a side, an angle, and a side that are proportional on the sides and congruent on the angles. So those are congruent. Similar triangles. So we're going to write out a proof. We're given that NK over ML is equal to JK over HL, and that shows the two sides are similar, that wrapper side, and that NK is parallel to ML, and that's given. Okay. From the given, we're given that the two lines are parallel. So because they're parallel, we know that those two angles are congruent that were previously marked. That's angle JKN is congruent to angle JLN And let's see, those are corresponding angles. Gotta start thinking here. Corresponding angles. And that gives us our setup for side angle side. So we know that triangle JKN is similar to triangle JLM because of side angle side similarity. And because they're similar, the last thing we can state is that there are other sides that are proportional. JK over HL is equal to JN over HM because of corresponding sides of similar triangles are proportional. So CSSTP. All right, there we can do one more little proof here. Angle Q and angle S are right angles. So we know those are congruent because they're both right angles. And then we have our congruent vertical angles, and these are going to be similar by angle similarity. And that's how we're asked to prove. So pretty easy proof here. Angle Q and angle S are right angles, and that is by given. So we need to state that angle Q is congruent to angle R by definition of right angles. So those are congruent. And then we need to state that angle PRQ is congruent to angle TRS because those are vertical angles. Okay. And then last but not least, we've proven two sets of triangles are congruent. So triangle PRQ must be similar to triangle TRS by angle similarity. All right, I'm going to go ahead and stop the video before we do the last two, just because the last two will take a bit of time, and this will be part one. So go on to part two.